Okay, we are live. So we are actually doing test review. Today is 11/15/18. Okay, so number one, we need to know whether it's either going to be direct variation, inverse variation, or neither. Okay, direct variation is when two numbers multiply to make the same number. X times y equals 24, right? And if we look at our notes, remember we looked at our notes, sure enough, that is definitely going to be inverse variation. We can go and look at our notebook if we want to double check that, but if we go straight to our notebook, section 6.1, inverse variation, xy equals number. Okay, boom, we got it. That's definitely inverse variation. Number two, if I graph this, I don't need to, but if I graph this, it would start at 3, and it would go up 3 or 4. It looks something like this. So to be a direct variation, it does have to be a straight line, but it can't go through any other number but 0. So to be direct variation, because it goes through 3, it's not. So this is neither. But on number 3, because it starts at 0 and goes up 1 over 2, up 1 over 2, it's going to be directly varies, because as it goes up 1, it goes over 2. Always. Up 1 is over 2. So it's directly related. So this one's direct variation, okay? So, not too bad. xy equals a number is inverse. If it's a straight line, but it has to go through 0 to be direct, this one's not. This one's a straight line. It does go through 0, so this one's definitely going to be direct variation, okay? And number 4 is a chart. So the first thing I do is I just check out the chart and say, okay, well, 2 times 1 is 2, 4 times 2 is 8, 24, 64. This one's not. It's not inversely varied. It doesn't. But what I do notice about these numbers is it sure looks like it's, let's see, 2 to the 1 power, 2 to the 2 power, 2 to the 3 power, 2 to the 4 power, so it's not going to be either one. Does that make sense? This one's neither. It's not a straight line. It's more of an exponential, isn't it? So this one's going to be neither. But I look at 5, and I notice that if I multiply, I get negative 8. If I multiply, I get negative 8. Multiply, I get negative 8. Multiply, I get negative 8. So it's got to be an xy equals negative 8. So this one's my inverse variation. Okay? Not too bad. Right? Not too bad. Okay? 6. So if I take a look at 6, it tells us it's inversely varied. Okay? So I know that if I look at my book, right, it says it's inversely variation. Here it is. Inverse variation is x times y equals a number. So, okay, I can do that. It's okay. X, y equals some number. So the number's got to be negative 15. You agree? Because it's negative 3 times 5. So there's my equation. And now there's 2 parts to this. The second part says, now find y when x equals negative 4. So I'll use my equation. I'll go negative 4 times y equals negative 15. So all I'm doing is plugging my negative 4 in for x. See? Negative 4 goes in for x. And we'll solve, and I'll go y equals negative 15 over negative 4. 3.75, I believe, if I use my calculator. Okay? Now on 7 through 14, I'm going to use a totally different sheet of paper because my work's never going to fit on my review sheet. Okay? So I'm going to do number 7 on regular paper. Okay? Anybody need regular paper? If you need regular paper, I got it. Okay? All right, 7. I have x squared plus 5x over x squared plus 10x plus 25. Okay, I must say this 3 times. Factor, then cancel. Factor, then cancel. Factor, then cancel. Okay, so let's factor. So if I take a look at the numerator, they both have an x in common, so I'm going to common factor out an x. If I common factor an x, I'll have an x plus 5. The denominator, multiples of 25 is 5 and 5. They'll make it 10. So I'm going to go parentheses, 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 parentheses. I'll multiply I'll factor it into an x plus 5 and an x plus 5. Factor, cancel. Okay, well the canceling's easy, right? X plus 5 with x plus 5. So my answer to number 7 is just going to equal an x over an x plus 5. How's that? Thumbs up?
Yep.
And if I get going too fast, will you please tell me, okay? All right, number 8. I have a 12y over a 6x to the 7th times a 4x to the 5th over an 8y to the 4th. Okay, now, I did say factor, cancel, but in this case there's no factoring to be done, right? So I'm just going to cancel. Well, if I look and I want to cancel, let's see what I have. Right off the bat, if I have, looking for a good pen, this pen I'm looking for. Let's see, 12 and 6, 2 and 1, right? 4 and 8, 1 and 2, right? Just canceling. Just cancel, reduce, cancel, reduce. Let's see, 5 of these x's on top will cancel 5 of these x's, so 5 of these x's cancel 5 of these x's, leaves x squared in the denominator. 1 of these y's will cancel 1 of these y's, so this y here in the numerator cancels 1 of these y's in the denominator, leaves y to the 3rd in the denominator. Okay, so cancel, cancel, cancel. Now let's just multiply. So you multiply straight across, and I'll get a 2 times 1 is 2 over a 1 times 2 is 2 times an x squared y cubed. Now wait, oh, there's more canceling. I can cancel a little bit more. 2 over 2 makes a 1, so my answer is a 1 over x squared y cubed. Cancel, 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 right? Thumbs up? Okay, number 9. Okay, number 9. Pen's dying on me. It's all right. So let's go. A 2x squared plus a 2x over an x squared, slide that up, x squared minus 3x times, right, an x squared minus x minus 6 over x squared plus 2x plus 1, okay? Factor, 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 cancel, 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 okay? All right, so first of all, first fraction, its numerator, I can common factor out of 2x. I'm going to common factor out of 2x. If I take out the 2x, I'll have an x plus 2 left over. The denominator of the second fraction, I can common factor out an x. So if I take out my x, I'll have an x minus 3 times factor, factor, factor. If I put a 1 here, it'll help, okay? Parentheses, parentheses. I'm going to use a negative 3, positive 2. Negative 3, positive 2, so x minus 3, x plus 2. And in the denominator, 1 times 1 makes 1, but they add to 2. So we've got x plus 1, x plus 1, okay? So cancel, cancel, cancel anything on the top with anything on the bottom. So let's see, x minus 3 goes to x minus 3. Oh, I did make a mistake and nobody caught it. It's okay. That has to be a 1. My mistake, that has to be a 1. My bad. I'm glad I found my mistake though. That has to be a 1 so that I can cancel, cancel. Oh, there's more to cancel too. See the x's?
Yeah.
I can cancel the x's too. Cancel, cancel. So my grand answer is 2 times my x plus 2 over my x plus 1. Okay. Thumbs up. All right, number 10. I'm going to turn my page when you're ready. Sky, give me thumbs up when you're ready. Good. Nikolai, you got it? Okay. Brian, you got it? Okay, turn the page. Number 10. All right. I'm going to have a 5x squared over 7y squared divided by a 15x squared, Katie, thank you, over 35y to the third. So, divide, right? So I'm going to flip my second fraction, right? So if I divide, I flip my second fraction. So I have a 5x squared over a 7y squared times 35y to the third over 15x squared, okay? Now, I flipped the second fraction, right? There's no factoring to be done, so there's no factoring, so I'm just going to cancel, okay? So, you ready? Let's see, 5 and 15 makes a 1 and a 3. 7 and 35 will make a 5 and a 1, okay? X squareds cancel out x squareds. Am I going too fast? Okay, so 7 and 35, right, Nikolai? I can divide both by 7, right? Which will leave a 1 and a 5. Okay. And the x squareds cancel, right? Y squared with y, 2 of these y's, I'll cancel 2 of these. 2 of these y's cancel 2 of these. I'll be left with just a y, okay? Now, what's left over? Let's see. So multiply straight across. 1 times 5 is 5 times y is a 5y, and 1 times 3 is a 3. How am I doing, okay? As long as you can factor, this test won't be too hard. Okay. All right, slide it up to number 11, okay? So 11, I'm going to have a 2x squared. Am I doing 11? Yeah, plus 5x plus 2 over x squared minus x minus 6 divided by x squared plus 3x minus 10 over x squared plus 2x minus 15. Okay, you ready? I'm going to factor, but before I factor, I'm going to flip. Let's divide by. I'm going to flip this one, okay? So let's flip the second fraction. So I got to rewrite the whole thing and flip it, okay? So here I go. It's going to take a little time, but not too bad. So I got to flip this one. So I still have a 2x squared plus a 5x minus plus 2, sorry, over x squared minus x minus 6 times, okay? I'm going to flip the second fraction. X squared plus 2x minus 15 over x squared plus 3x minus 10, okay? So I flipped it. Now I'm going to factor, okay? So if I factor the top of first fraction, 2x and x, I'm going to go plus 1 and plus 2. And if you check your double smiley, you will get your 5. 2x, 1x, right? If you check your double smiley, you get the 5x. Over, factor, x minus 3, x plus 2. Negative 3 times 2 makes negative 6, but negative 3 and a negative 2 add together make a negative 1. Times, okay, factor, x plus 5, x minus 3, multiples of negative 15 and make a positive 2. If I factor the bottom, the denominator, I'll go x plus 5, x minus 2. Okay, now here comes the fun part. Factor, we get to cancel, and I like that part. Let's see, x plus 5 with x plus 5, right? X minus 3 with an x minus 3. X plus 2 with x plus 2. Thanks, Nikolai. I don't know how I missed that, but I did. Thank you. So what's left? A 2x plus 1 over an x minus 2. Okay. How's that? Okay, you guys ready for 12? Okay, 12. I've got an x minus 3 over 2x plus 1, subtract an x plus 9 over a 2x plus 1. Okay, now, when we add, we need, or subtract, we need a common denominator. Okay, Sure, Brian. Here, why don't you grab it down here, okay? So when we add or subtract, we need a common denominator. We already have one, don't we? We already have a common denominator. So let's go straight to 2x plus 1. That's my denominator, right? And what do I have in the numerator? I've got a x minus 3 minus x. You got to be careful. Because I need to go the negative into the 9 also, right? Minus 9. Okay, let me simplify that. So I still have my common denominator, but on top I've got to have a, oh, the x's cancel, don't they? X's cancel. I'll have a negative 12 over 2x plus 1. Nikolai.
Oh, sorry, I don't know.
It's okay. It's all good. You're just stretching. Okay, so far so good? If I get going too fast, tell me, okay? Okay, 13. Slide it up. 13, I've got a 5x over an x plus 2 plus an x plus 12 over an x plus 2. Okay, common denominator. It's already there, right? I already have a common denominator. This gets easy, I think. So go straight to x plus 2, okay? So now we can just add. I'll go, all right, I can go 5x plus x plus 12, right? So I'm just going to put the numerators together. I already have a common denominator. 5x plus x is a 6x plus 12 over, no, just 5x plus x, just 6x plus 2. Okay, now, normally I would be done, but I think I can do more. Normally be done, but I think I can do more. I think I can common factor. Okay, watch this little trick. If I common factor out a 6, I'll have an x plus 2. Yeah. Nice, huh? So by common factoring, in this case, I can cancel, and my answer is just 6. Nice. You will have one like that tomorrow, okay? Just be wary. Be careful, okay? 14, how am I doing, okay? Turn the page. Flip my page. Okay, let's do number 14. Yes. If you want full credit, yes. Okay, 14. I have x squared plus 2x over x squared plus 5x plus 6 minus 1 over x plus 3. Okay, I need a common denominator. So I'm thinking if I factor this, one, it'll help me get a common denominator, okay? So if I factor this, it'll factor into an x plus 2 times an x plus 3, right? If I factor the denominator. Now, if I look at the two fractions, they both have an x plus 3. But to have a common denominator, I need to give the second fraction an x plus 2. So I'm going to do that. I'm going to go ahead and give it an x plus 2, x plus 2. And then if I do that, I have my common denominator, x plus 2, x plus 3 over, well, let's see. I'm going to have an x squared plus 2x. I'm going to have this negative. Watch, I'm going to go minus 1x minus 2. Okay, so I got the negative 1x and a negative 2. You okay with that? My negative 1x and my negative 2. Okay? Now, let's tidy this up. X squared plus a 1x minus 2 over an x plus 2, x plus 3. Now, can I go further? I think so. I think I can go further on this one. If I factor the numerator, scoot that up. Let me factor the numerator into an x plus 2x minus 1. I think I can cancel, right? Cancel. My grand answer of x minus 1 over x plus 3. We're getting there. We are getting there. We really are. We're close, okay? Okay. And I can do it. Katie, I can do this. I know. It's still shorter than it was third period. Remember I told you I tried to record third period and it didn't work. Okay, now 15 has a mistake. And I'm going to fix it for you. So on 15, everybody write this. Put a negative right there. Fix it. Put a negative right there. Make that a -1, okay? That's my mistake. I have to fix it, okay? Put a -1 right there. Everybody see that? Make it a -1, okay? So I'm going to go -1 over x equals x plus 2 over 1, okay? So if I've got a fraction equal to fraction, I'm just going to cross multiply, okay? I'm just going to go this times this equals this times this, okay? So I'll get a 1 times -1 is -1, and I'll get an x times an x plus 2, okay? So fraction equal fraction, cross multiply. I'm going to distribute. -1 equals x squared plus 2x. How am I doing? X squared, I'm thinking I'm going to need to factor, so I'm going to set it equal to 0, okay? So I'm probably going to try and factor +1 plus 1. Set it equal to 0 and factor x squared plus 2x plus 1. So I brought the 1 over. Just brought the 1 over. That's all I did is I brought the 1 over. And now it'll factor, okay? Factor, 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 factor. X plus 1, x plus 1, right? Because 1 times 1 makes 1, but when I add them together I get 2, right? Mini equations, 0 equals x plus 1, 0 equals x plus 1, and if I solve I get -1 twice, but we really only need a 1. So you guys agree? X equals -1. It happens twice, but one answer, okay? Okay, you ready for 16? 16. Now 16 is kind of the big one. 16 might be the hardest question on the test, but I'll go through it slowly with you. Okay, 16. I have, actually I thought, you know what, maybe 14 was the hardest. We'll do 16. -2x. I don't think any of them are hard, but you know, that's me. X plus 2 plus x over 3 equals 4 over x plus 2. Okay? Now, here's what I want to do. I want to get a common denominator, okay? So, I'm going to multiply this one by 3 over 3, all right? Multiply the second fraction by an x plus 2 over an x plus 2. And the third fraction I'll multiply by 3 over 3, right? So I've created a common denominator. My common denominator really is 3 times x plus 2, right? Okay, I created a common denominator, okay? So that's what's on the bottom. But on the top, in the numerator, I just have to simplify. And I get a -6x plus x squared plus 2x. And on the other side, I'll get a 12. How am I doing? We're going too fast? Or okay? Right. Let me tidy this up. So I have an x squared plus 4x over a 3 times an x plus 2 equals a 12 over a 3 times an x plus 2. Now, I taught you this trick yesterday, and I'm going to use it right now, okay? If I've got the same denominator, right, what I could do is multiply both sides by the 3 over x plus 2 over 1 and 3 over x plus 2 over 1. And the reason I like to do that is because the whole point of doing this, like now we can just cross off. It cancels out our denominator, okay? So once I get rid of my denominator, it becomes a pretty simple problem, okay? So Cody, were you here yesterday? Okay, so think about this. Go back to what's in black, okay? And remember, if it's an equation, what I do to one side, I got to do the exact same thing on the other side, right?
Yeah, I was just trying to see what you did. We scribbled it all out.
Okay, so you're ready? So if I multiply by the denominator, so if I multiply both sides by 3 times x plus 2 over 1 to both sides, right? It's a cool little trick because by doing that, it allows us to cancel, 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 and what we're left with is a...
minus 4x.
Yes, thank you. So Cody, by doing this little trick, it allows us to get rid of the fraction completely, doesn't it?
Yeah.
And it only works, though, if you can get a fraction equal to a fraction that have the same denominator, okay? And once you do that, it's really cool because now it's just, thank you, x squared minus 4x equals 12, right? Fraction's gone. Now you weren't here yesterday when I showed that, but it's a nice little trick, isn't it? But it only works if you've got a fraction equal to a fraction with the same denominators, okay? So then, I'm going to bring over the 12. In fact, Cody, a lot of times I don't even show that step, but I knew you weren't here. A lot of times I just cross out the denominator, okay? So, let's bring over the 12, x squared minus 4x minus 12 equals 0, right? Let's factor x minus 6, x plus 2 equals 0, right? Many equations, one answer is x equals 6, and many equations, x equals negative 2, right? Except I'm going to throw out the negative 2. I will throw out the negative 2 because if you put the negative 2 right there, put the negative 2 right here, you will divide by 0, right? You can't divide by 0, so you throw out the negative 2. So you got to check your answers tomorrow, okay? You'll have one of those. My answer is just 6. Does that make sense why I threw out the negative 2? Yep, you can't divide by 0, right? Just as long as this worksheet. Okay. All right. 17. Okay. Ready? 17. I'm gonna get some graph paper out. Okay. 17. I've got my f of x equals my x plus 5 over my x squared plus 3x minus 10. Okay, now I'm going to put in my calculator first because that's probably what you guys are going to do. The same thing. You guys agree? You're going to go straight to your calculator. Maybe not you, but you know the rest of them. They're going to go straight to the calculator. Okay. You're going to get to like this calculator after a while. So I have to have in my calculator. It's super important. I have parentheses. Okay, because you need the entire top divided by the entire bottom. So I'm just going to go parentheses x plus 5 divided by parentheses x squared plus 3x subtract 10. Okay, parentheses. Graph it. Okay, goes crazy. It totally goes crazy at 2, doesn't it?
Yeah.
So if we go back to our problem and we factor, okay, so let me factor this. If I factor this, x plus 5, I'll have an x plus 5 and an x minus 2, okay? Now, if I factor the denominator, remember, you can't divide by 0, right? So here's what x cannot equal. Cannot equal negative 5, and x cannot equal 2. Well, then, my graph and my calculator kind of makes sense, because where's this asymptote? It's at 2, isn't it? Because x cannot equal 2. So if I go ahead and put my graph down, and I draw in my asymptote. Let's see where I better drop my pen. Oh, dropping things all the time. So right at 2, I'm going to put my asymptote, right? My graph looks something like this. Look at my calculator, looks something like this. And something like this, okay? Now, we also said x cannot equal negative 5. At negative 5, 1, 2, 3, 4, 5, we're going to have a hole at x equals negative 5. We're going to have a vertical asymptote at x equals 2. Now, I'll show you the hole in a second, okay? So if you take a look at the calculator, and I go to my trace button, and I go straight to negative 5, it doesn't have a corresponding y value, does it? It doesn't exist. It's not part of the graph, okay? So it won't show the hole on the calculator, but it has a hole at x equals negative 5, okay? When you get to calculus, you're going to do a lot more of this, but at least when you get to calculus, you're going to say, oh yeah, Mr. Davies told us there was a hole there, and you're going to go and find out exactly where the hole is and exactly why there's a hole, okay? Okay, moving on. Okay, all right, last but not least, it's a little bit of a story problem, but it's not a hard story problem, okay? So you ready? Beth can tile a floor in 10 hours, okay? And so by herself. So she can do the one job in 10 hours, okay? But if she works with Tom, so if they add their work, they work together, he can do his job in, well, we don't know, X hours, okay? if they work together, it's going to take 5.8 hours. So she can do one job in 10 hours. He can do one job in, we don't know how many hours, X hours, right? So it's a ratio, right? They work together, if they add them together, it takes them 5.8 to do the one job. Okay, it equals 1 because they're going to do one job, not 2, but one job, okay? Now, there's the equation. It's not a hard equation. We just need to simplify this, okay? So, that's the same thing as a 5.8 over 10 plus 5.8 over x equals 1. If I want to add these two, I need a common denominator, right? Multiply this fraction by x over x. I'll multiply this fraction by 10 over 10. All right? I need a common denominator. I'll have a 5.8x over 10x plus a 58 over a 10x equals 1. How am I doing? Am I doing okay? I have a common denominator, right? So let's make it a 5.8x plus 58 over 10x equals 1, okay? Let's solve. Cross multiply, right? I'm going to have a 5.8x plus 58 equals 10x times 1 is a 10x, right? Okay. Minus 5.8x minus 5.8x. I'm running out of room, so I'll squeeze it over. I'll bring it up here. So I'll have a 58 equals a 4.2x, right? Divide by 4.2. Let's see what I have. 58. Oh, clear. 58 divided by 4.2, and I get an answer of about 13.8 hours. So Beth is a harder worker. Tom is a slacker.
We've been recording for 32.
I know.